So this is Ms. Pathlin, and I am going to be going over lesson 17.4 and 17.5, solving systems of linear equations, classifying systems of equations. To master this concept, I can classify systems of equations by the number of solutions. So you're classifying systems by the number of solutions. So we've talked about this before. So there can be no solution, one solution, or infinitely many solutions. I can recognize when a system has no solution, one solution, or infinitely many solutions. Vocabulary: system of linear equations, solution of a system, substitution, elimination. All right, so I want you to answer number 1 on your own. So remember, if you just watch the video through, you're not following directions and you're not going to get as much out of it. You need to practice on your own, and then you're using the video to check your answers. So right now I want you to pause, work with your table group, ask for help. Use Desmos down here. It says graph the system. You may either graph by hand or you may use Desmos. So you're already on your computer. Go to Desmos, type in those equations. All right, pause this and then come back to check your work. All right, so it says consider the system. Y equals negative 2x plus 2 and y equals negative 2x minus 2. What do you notice about the slopes of the line? Well, remember, if we have it in slope-intercept form, that coefficient is your slope. So you should notice that they both have the same slopes. The slopes are equivalent. M equals negative 2. What do you notice about the y-intercepts? Well, our y-intercept is our b value. So I notice that one's positive 2 and one's negative 2. The y-intercepts are different. One is 0, negative 2, and the other is 0, 2. What conclusions can you draw from that information? So this is review. We've talked about this before. If the slope is the same and they have different y-intercepts, the lines will be parallel. The lines will be parallel. And since we're getting into solving systems, and we need to be able to identify if it has no solution, one solution, or infinitely many solutions, when it is a solution, the graphs intersect. They would overlap or touch at the same point or points. Well, if they're parallel, they will never intersect. So, and the lines will be parallel and have no point of intersection. Never touch. D, graph the system. Use a different color for each line. You may either graph by hand or you may use Desmos and then sketch the right. I definitely would practice graphing by hand and then using Desmos to check your answer, because it's definitely a skill you need to have. So let me grab 2 colors. I'm going to leave colored pencils out with this Costin, so definitely use the colored pencils, or if you have your own pens or colored pencils, please use those. All right, so we have, let's graph the first one, y equals negative 2x. I'm just going to write it in this color so I know this is my line in this pink color. So always graph the y-intercept first, plus 2, that's 0, 2 on the y-axis. Then I know my slope is negative 2. I always create a fraction, so then I know my rise over run. So for my y-intercept, I'm going to go down 2, right 1. And then I just keep going that same pattern, down 2, right 1. Also, we want to show all the solutions on the graph, so I need to go the opposite direction from my y-intercept, up 2, left 1, up 2, left 1. All right, always use your ruler to connect your points on a graph. So grab your ruler if you haven't. And then connect our points. All right, that is my line for y equals negative 2x plus 2. Now I'm going to do in green y equals negative 2x minus 2. So now I'm starting at the y-intercept of 0, negative 2, and then same slope. Down 2, right 1, down 2, right 1. And then opposite direction, up 2, left 1. All right, connects the points. What do you notice about the graph of the two lines? Well, I notice that they're parallel. They are parallel lines. What do you notice about the point of intersection? There is no point of intersection. Solve the system algebraically, substitution or elimination. How many solutions does the system have? So in order to solve this, I want to first think, what would be easier? You know, you can always do either one, but there is usually an easier route. One might take a little longer than the other. If they both have y equals, I can set them equal to each other because they both have their variable isolated with y equals. So if they both are y equals, you just put them both equal to each other. So I'm going to put negative 2x plus 2 equals negative 2x minus 2. So I'm using substitution here because if it's y equals, then I'm plugging in for y equals. So I plugged this part of the equation in for this y up here. And then I set it equal to the other side, negative 2x plus 2. Or actually, I just realized I did the inverse. If it was plus 2, so I plugged this first equation in for this y. So when they're both y equals, you set them equal to each other. All right, then I want to solve for x. So, I mean, you can start with your constants. Again, it doesn't matter when you have a variable term and a constant term on both sides. So to make it easier, you might let's just maybe always say start with your constants when you have both terms on both sides. So I'm going to start with this side plus 2. I'm going to do the inverse minus 2 to both sides. Negative 2x equals negative 2x minus 4. Now I need to move my variable terms, plus 2x plus 2x. Now, when you cancel something out and you're left with nothing on that side, then you still need to write a number. You need to write 0 equals negative 4. 0 does not equal negative 4. So that means there's no solution to these systems. And that's what we get when we have parallel lines. If there's no point of intersection, then there's no solution, because the solution is when both systems, when both lines intersect. So this proves it algebraically. All right, consider the next system. Y equals negative 2x plus 2 and 6x equals 6 minus 3y. Somehow that accidentally got on this page. It should be on the next page with the graph. So I'm going to rewrite it on the next page so that we can reference it. So it's y equals negative 2x plus 2 and 6x equals 6 minus 3y. Go ahead and rewrite it so you have it on this page. All right, so first, what do you notice about the slopes of the line? Well, before I can even identify the slopes, I'm noticing that my second equation, starting with 6x equals, that's not in slope-intercept form. I don't know what the slope is right now, so I need to rearrange that into slope-intercept form. So I need to get the y term by itself on the opposite side. So what I'm going to do is I'm going to go 6x equals 6 minus 3y. I'm going to add 3y to both sides because I want to get that y term on the left. So then I'm going to get 3y plus 6x equals 6. Then I'm going to subtract 6x from both sides. So I get 3y equals negative 6x plus 6. All right, and then I need to get y isolated, divide by 3, divide everything by 3. So then it's negative 6 divided by 3 is negative 2x, and 6 divided by 3 plus 2. All right, so now go ahead and pause the video, and I want you to answer A through G by yourself. This is more review. You should know how to graph equations in slope-intercept form, and we've talked about how to identify the slope, the y-intercepts, and we've also already done the lessons on substitution and elimination. So pause the video now, and then come back to check A through G. All right, so what do you notice about the slopes of the line? Well, I notice that they're both negative 2x, or just negative 2. Remember, x is not the slope. So they are the same. The slopes are the same. M equals negative 2. What do you notice about the y-intercepts? Well, I also notice the y-intercepts are the same. They are the same. 0, 2. What conclusions can you draw from the information? The two lines are the same. It will be the same exact line if I graph it. So let's check it. Graph the system. Use a different color for each line. You may either graph by hand or you may use Desmos and then sketch to the right. All right, so I'm going to do y equals negative 2x plus 2 in this color. So I have 0, 2. Then I'm going down to right 1. All right, then I want to connect my points. And then in my other color, I'll do y equals negative 2x plus 2. And I'm going to start at the same place. And then all of my other points are going to be exactly the same. Same slope, same y-intercept. So then I'm just going to kind of draw a line right on top of it. What do you notice about the graph of the two lines? Well, as we talked about before, the two equations represent the same line. What do you notice about the point of intersection? Well, they're intersecting at all points on this line. The two lines intersect at all points. So we would call that infinitely. Now let's solve the system algebraically. Substitution or elimination. How many solutions does the system have? So I'm actually going to practice using a different form just to switch it up and practice using different methods. So I'm going to use substitution. Oh, I guess I used substitution on the last one. I'm still waking up right now. So I'm going to use substitution because that's the easiest one. Again, you want to go with the easiest one. When you have a variable isolated, y equals, you want to use substitution. So I'm going to substitute negative 2x plus 2 for y in that second equation. So I'm going to write 6x equals 6 minus 3, but instead of y, I'm going to plug in what y equals up here, negative 2x plus 2. All right, now I'm going to solve for x. So 6x equals 6. All right, distribute. Negative 3 times negative 2x. Remember, negative times a negative is positive, plus 6x. Negative 3 times positive 2 would be negative 6. All right, then I want to combine my like terms. 6 minus 6 is 0. And then I want to subtract my variable term, minus 6x, minus 6x. Those both cancel out. Again, you have to write some number there. So we would put 0 equals 0. And that is true. Infinitely many solutions. Remember, when they both equal the same on both sides, that's infinitely many solutions. All right, consider this next system. Y equals negative 2x plus 2 and y equals 3x plus 2. Pause the video and do all of the ones for number 3, so A through G again. All right, you should have paused the video to do these. So now let's go over them. So what do you notice about the slopes of the line? Well, in this one, it's negative 2, and in the second one, it's 3. So the slopes of the two lines are different. What do you notice about the y-intercepts? Well, now I'm noticing that they're the same. They're both plus 2. So the y-intercepts are the same at 0, 2. All right, what conclusions can you draw from that information? The lines are on the other page. Well, going back to what we talked about in the previous lessons, if they have different coefficients, so if they have different slopes, but this, the same y-intercept, I know that these lines will probably intersect at one point. So they will have one point of intersection. And if they both have the same y-intercept, then they're going to intersect on the y-intercept at the y. But since they have different slopes, I know those lines are then going to go different. I mean, one is negative and one's positive. So they're going opposite directions from each other, but they're going to intersect at that one point at the y-intercept. So if we graph these, I'm going to graph, it was y equals negative 2x plus 2 in green. Remember color code, do your two different colors. All right, so y-intercept is 0, 2. We have another negative 2, so we're going down 2, right 1. Then up 2, left 1. Connect my points. All right, now I'm going to do the other one in blue. It was 3x plus 2. All right, so same y-intercept here. And then 3x, so that's 3 over 1, positive 3, so I'm going to go up 3, 1, 2, 3 over 1. Go the opposite direction, down 3, left 1, 1, 2, 3, down 3. All right, so so my prediction was correct based on the algebraic equations. They intersect at that one point. You also could say, you notice that they're going opposite directions. One has a positive slope, one has negative. It kind of forms that X. What do you notice about the point of intersection? The point of intersection is on the y-axis at 0, 2. Solve the system algebraically. Well, again, if they are both y equals, then I just am going to set them equal to each other. negative 2x plus 2 equals 3x plus 2. Solve. All right, so let's maybe just get in that habit of doing the constants first. So if I have plus 2 on both sides, I'm going to subtract 2, negative 2x equals 3x. All right, then it doesn't really matter which side I go to. So I guess I'll just do plus 2x. I like to get rid of negatives. Again, these cancel out, so I have to write 0. 3x plus 2x is 5x. And then I need to get x isolated, so I divide by 5. 0 divided by 5 equals 0. So x equals 0. And that goes back to our solution. Our solution is 0, 2, where x does equal 0. So then to prove that algebraically, I would plug in x equals 0 to one of these equations. So I like to go with my positive numbers, so I'm going to do y equals 3 times 0 plus 2, y equals 2. So these are the two x and y values for our solution at 0, 2. All right, number 4, another system to consider. So go ahead and work on this one. A through G. Pause the video now. All right, welcome back. So what do you notice about the slopes of the line? All right, so here I'm noticing they're different. This first one's negative 2, second one's 3. The slopes are different. What do you notice about the y-intercepts? Well, this one is b equals 2, the second one is b equals negative 3. The y-intercepts are different. So what conclusions can we draw from these? If they have different slopes and different y-intercepts. Now, even though the point of intersection up here, they had the same y-intercept, well, they also should intersect at one point if they have different, as long as it's both different slopes and different y-intercepts. The lines will intersect at one point. As long as they're different slopes. It can be the same y-intercept or it can be the different. All right, now let's graph it on the next page. Again, use a different color for each. You may use Desmos. So I'm going to do green for y equals negative 2x plus 2. Geez, this one seems very common. All right, 0, 2 on the y-intercept, down 2, right 1. And then opposite direction, up 2, left 1. Connect our points. All right, and then the other one was y equals 3x minus 3. So my y-intercept is at 0, negative 3. My slope is 3 over 1. 1. As I was doing my points, I noticed where that intersection was. It's on this point. All right, connect our points. Oops, my ruler kind of moved out of the way there. What do you notice about the graph of the two lines? Well, I noticed that they have one point of intersection. What do you notice about the point of intersection? Well, as I was graphing it, I noticed it was on the x-axis at 1, 0. Solve the system algebraically, substitution or elimination. So again, if they're both y equals, set them equal to each other. That would be the easier method. Less steps. All right, so let's start with constants. So if I have plus 2 with minus 2, negative 2x equals 3x minus 5. Then I'm going to do minus 3x to both sides. Negative 5x equals negative 5. Divide by negative 5. X equals 1. Go back to our graph. It intersects at x equals 1. Now let's make sure y equals 0. So I'm going to plug it, x equals 1. I'm going to plug it into this second equation. Y equals 3 times 1 minus 3. Y equals 3 minus 3. Y equals 0. So our point of intersection, our solution, is 1, 0, proven algebraically and graphically. All right, 5, let's write a conjecture together. Write the conjecture about the two solutions of the system, about solutions of the system of inequalities based off what you've discovered above. This should be system of equations. We have been doing equations, not inequalities, and the system of inequalities will be in lesson 18. So if two lines are parallel, then they will never intersect and have no solution. If two lines have the same slope and same intercept, then they are the same coinciding, we call them. So that's a vocabulary term that you want to be familiar with. If they're the same, they're coinciding line and have infinite solutions. And if two lines have different slopes, so again, with the last one, they just have to have different slopes. They can have same or different y-intercepts. As long as it's different slopes. Like, notice how A and B, for parallel lines, they're going to have the same y-intercept. Parallel lines, they're going to have different y-intercepts always, but the same slope. And then for B, they're going to have the same slope and the same y-intercept. I'm going to add that. Same slope, different y-intercept. So if the two lines have different slopes, they can either have the same or different y-intercepts, and they will intersect at one point and have one solution. All right, we're actually going to skip the foldable. I didn't have access to it. I asked the other algebra teachers from last year, and I guess they don't have it anymore, so we're just going to skip this, and you'll just have to use your notes. All right, last thing, critical thinking questions. Consider the following system of equations. What number would you replace C with to make that system have infinitely many solutions? Explain how you know, and explain why, even though you can change C to any number, this system could have no solution. So go ahead and pause this video and try it on your own, and then let's come back and talk about it. All right, so for A, what number could you replace C with to make this system have infinitely many solutions? Well, going back to what we just wrote down, to have infinitely many solutions, they have to have the same slope and same y-intercept. So if I know that when I solve these equations, then I'm looking at how it's set up. I could use elimination to eliminate everything. So if C, like, notice how it's like doubled. 3x and then negative 6x. 12 and negative 24, it's like that number times negative 2. So if we want them to be the exact same slope and same y-intercept, they have to be the same equation to be infinitely many solutions. So as long as I multiply every single term by the same number, it's equivalent. So if 3x times negative 2 is negative 6x, then 4y times negative 2, which would be negative 8y, and then 12 times negative 2 is negative 24. So if you do the same operation to every single term in your equation, it's going to be the exact same. That's equivalent. So C would have to equal negative 8. Then negative 6x minus 8y equals negative 24 is coinciding with 3x plus 4y equals 12 because mathematically negative 2 times 3x plus 4y equals 12 equals negative 6x minus 8y equals negative 24. So they are coinciding lines with infinitely many solutions. Explain why, even though you can change C to any number, the system could never have no solution. Well, let's see why it could never have no solution. So no solution, hey, I'm recording a video right now. So with no solution, you would have to, going back up here, two lines are parallel, they have the same slope and different y-intercepts. So let's see why they would never have that. So I want to rearrange these into slope-intercept form just to better understand them. So if I have 3x plus 4y equals 12 minus 3x to both sides, 4y equals negative 3x plus 12. Divide everything by 4, y equals negative 3/4 x plus 3. Then if I do the other equation, I'm just going to keep it c, negative 6x plus cy equals negative 24 plus 6x plus 6x, cy equals 6x minus 24. So let's just say I'm dividing by c. So let's think about it. Explain why, even though you can change c to n, it would never have no solutions. Well, maybe let me just plug in a number for c. Like, what if I did c equals 6? So then I'm dividing everything by 6. It would be y equals x minus 4. Well, I'm always going to have a different slope and a different y-intercept. So for it to have no solution, it has to have the same slope. But I don't know if I can ever have the same slope and a different y-intercept. Like if I plugged in c equals 4. 6 divided by 4 would be 6/4 x. If we simplified that, that'd be 3/2 x. And then again, that's a different slope. So no matter what I plug in, it's always going to have a different slope. So no matter what we plug in for c, it will always have a different slope. And to have no solution, they must have the same slope. All right, that concludes the video. So please make sure you complete the other tasks that are on the course calendar. Make sure you are also working through those extra practice on Delta Math if you have time, and if not in class for homework. This will definitely help you be more successful for the test and in general. Thank you, bye.